Good morning. In today's session, we are going to start a new topic, which is Laplace Transform. It is a very important topic. You can expect more questions from this session. So here, the only thing is that you will have to study a lot of formulas. So when you are given a question, you will have to identify to which type the question belongs to, and then apply the formula accordingly. Okay, so it's simple to learn, but the only thing is that, as I said before, you will have to come across a lot of formulas. So whenever you come across a formula, you just write it in a separate paper. So when you revise, it will be easy to go through all the formulas together. Okay, so let us begin. Laplace transforms. If a function f of x is defined for all positive value of x, that is x greater than 0, then Laplace transform of a function f of x is given by, this is how it is written: Laplace transform of the function f of x equal to integral 0 to infinity e raised to minus sx fx ds. This is a formula to find the Laplace transform of a function. This can again be written as f of s, where s is a parameter. It can be either real or complex. So Laplace transform will be a function of s. So we denote it as f of s. Okay, so this is a formula that you have to study. Laplace transform of a function f of x is equal to integral 0 to infinity e raised to minus sx fx dx. Now let us study the Laplace transform of some elementary functions. First, let us find the Laplace transform of a function e raised to ax. Okay, first form, f of x is this. This is your formula. In place of f of x, you just write e raised to ax. Then take the common term, integral 0 to infinity e raised to minus s minus a of x dx. Just you are grouping. Then perform the integration and apply the limit. I am not explaining integration because that's a very simple one that you can easily follow. So the answer of Laplace transform of e raised to ax, this is a formula: Laplace transform of e raised to ax equal to 1 by s minus a. Okay, if you have given a question of the form Laplace transform, that is e raised to x, then its Laplace transform is 1 by s minus a. So your question will be like this: Laplace transform of e raised to 3x. So definitely you understand that it belongs to the form e raised to ax. Okay, what was the formula? 1 by s minus a. Here what is your a? In place of a you have 3. So your answer will be 1 by s minus 3. See. Now next one, Laplace transform of e raised to minus 40. That is also of the form e raised to ax. Formula 1 by s minus a. Here in place of a you have minus 4. So s of minus 4. It is nothing but 1 by s plus 4. Okay. Now, so that is the first formula that you have studied. That is Laplace transform of e raised to ax equal to 1 by s minus a. Now, next formula. That is, if you are asked to find the Laplace transform of a constant, say a, then function formula, instead of f of x, write a, perform the integration and apply the limit. Formula is a by s. That is, if you are having a constant, say a, you are asked to find the Laplace transform of a constant a, then your answer will be that constant divided by s. See the example. What is Laplace transform of 2? 2 is a constant. So your answer will be that constant, that is 2 divided by s. Laplace transform of minus 5 by s. Laplace transform of 1 by s. Okay. So that is the next formula. So Laplace transform of e raised to ax is 1 by s minus a. Laplace transform of a constant, say a, is equal to that constant, say a, divided by s. So you have studied two formulas. Now, this is a possible derivation that can be asked separately. That is, find the Laplace transform of 1 by root x. Function formula, in place of f of x, write 1 by root x. Make a substitution, that is, let sx is equal to y. So s dx will be dy, or dx equal to dy by s. When x equal to 0, y is 0. When x equal to infinity, y equal to infinity. Now make those substitution in equation 1. So equation 1 will now reduce to like this. Okay, that is, x is y by s. Okay, so y by s whole raised to dx is dy by s, like that. Now here 1 by This again reduces to this one. 1 by s raised to half is a constant, so just take it out. So you will get like this. Rest everything is kept as such. Now y raised to minus half can again be written as y raised to half minus 1. This is kept as such. Now this term is equal to gamma 1 by 2. Now the value of gamma 1 by 2 is root pi. Root s is kept as such. So Laplace transform of 1 by root x is root of pi by s. So study this derivation very well. Next, another formula, Laplace transform of sin a t. So here a question is in t, so just replace x with the t. Okay, so this is your function formula. Place of f of t, write sin a t. Now this equation is of this form, right? That is, in place of a you are having minuses, and in place of b you are having a. So this is a formula to evaluate this integral. Similarly, by comparing this one with this one, you can write this one as this one. Okay, that is, just compare these two. In place of a you are having minuses, and in place of b you are having a. So just make the substitution in this formula, that is e raised to at. Your e raised to at will be e raised to minus st. See, because your a, in place of a you are having minuses, right? Then what is a square plus b square? That is minus s the whole square, that is s square plus what is your b? A. Okay, so b square, instead of b square you will have a square, then a minus s sin bt, that sin 80, minus, in place of b you have a, cos, in place of b you have a. Then apply the limit, and the answer will be a by s square plus a square. So Laplace transform of sin 80 equal to a by s square plus a square, another formula. So your question will be this: Laplace transform of sin 3t. It is of the form sin 80. You identified the form. What is the formula? A by a square plus a square. Here what is your a? It is 3. So 3 by a square plus 3 square. Write it as 3 square itself. Don't write it as 9. Okay. Now sin 5x. That is also of this form. So that will be a. Your a is 5. 5 by a square plus 5 square. Now similarly cos 80. Integration and everything, the steps are the same. The only thing is that there will be a slight change in the formula. So I am not explaining it again. Laplace transform of cos 80 is s by a square plus a square. So see the difference. Laplace transform of sin 80 was a by s square plus a square, whereas Laplace transform of cos 80 is s by s square plus a square. Okay. See the example. Laplace transform of cos 4x. It is of the form cos 80. Right. So what is the formula? S by s square plus a square. That is s by s square plus 4 square. Similarly, Laplace transform of cos t. S by s square plus 1 square. Now, another formula. If you are asked to find the Laplace transform of a variable, say t function, formula, in place of f of t, write t. Then just rewrite this one as e raised to minus st as d of e raised to minus st by minus s. Minus 1 by s is common. Take it out. Rest everything is kept as such. Then first function into integral of second minus integral of derivative of first into integral of second dx. And apply the limit. You will get the answer as 1 by s square. So Laplace transform of a variable, say t, is 1 by s square. So this is also a derivation that you have to study, just like 1 by root x. So Laplace transform of 1 by root x is 1 root of pi by s, that we have already discussed. That derivation you have to study separately. Similar to that, you have to study this definition derivation also separately, that is Laplace transform of a variable, it is 1 by s square. Now another formula, e raised to 80 sin bt. What was the Laplace transform of sin 80? A by a square plus a square. What about cos 80? s by s square plus a square, right? So now here there is an additional term, that is e raised to at sin bt. Okay, so this is a formula. Just make the substitution here. Just group the common terms. This is written here. Similar to that we have derived for sin 80. This is also of this form. So make the corresponding changes. That is here also that is of this form. This one here, in place of e raised to 80 you will have e raised to minus of s minus 80, because your a is here minus of s minus a. Okay, so just, and b is b itself. Okay, so just similar to the derivation that we have done for sin 80, you have to do the integration for this also. Finally you will get the answer for Laplace transform of e raised to 80 sin bt as b by s minus a the whole square plus b square. So just go through the derivation, but for your exam you will be asked only problems. Okay, so you will be asked like a question like this: e raised to minus 2x sin 3x. So definitely you will understand that this is of the form e raised to 80 sin bt. Okay, what is the formula? b by s minus a the whole square plus b square. Here what is your b? 3. It is written here. S minus a the whole square. So here it will be s plus 2 the whole square plus b square. Okay. Similarly this one. Now next one is cos term, that is e raised to 80 cos bt. Derivation is similar to that for e raised to 80 sin bt. Just go through the derivation. See the difference. Answer is s minus a by s minus a the whole square plus b square. So when the given question is of the form e raised to 80 sin bt, answer is b by s minus a the whole square plus b square. When the question is of the form e raised to 80 cos bt, answer will be s minus a by s minus a the whole square plus b square. Denominator is the same. The only thing is that if when it is sin, numerator will be b. When it is cos, numerator will be s minus a. Okay, now these are the problems. See, cos term. So s minus a, your a is 3, s minus a the whole square plus b square. Examples. Last one is Laplace transform of x raised to n. Function, formula, substitution. As before, just rewrite e raised to s and ss as d of e raised to minus sx by minus s minus 1 by s is taken outside. Rest everything is kept in as such. Then apply the formula. First function into integral of second minus integral of derivative first into integral of second dx. Then here n is common, take it outside. So this will be the answer. So Laplace transform of x raised to n will be n by s Laplace transform of x raised to n minus 1. Okay. Now similarly for each term we can find, that is Laplace transform of x raised to n minus 1 will be n minus 1 by s into Laplace transform of x raised to n minus 2. Then Laplace transform of x raised to n minus 2 will be n minus 2 by s into Laplace transform of x raised to n minus 3. Similarly that goes on, and it will be similar like a progression. Finally the Laplace transform of x raised to n will be equal to n factorial by s raised to n plus 1. Okay, so here Laplace transform of x raised to n is n factorial by s raised to n plus 1. Here your x raised to n is 1. Okay, so 1 factorial by s raised to 1 plus 1, 1 by s square. Okay, this is an example. So study all these formulas write it in a separate paper and work it out, because for your exam you can expect problems only. Okay, so first when you are given a problem, you have to identify to which type it belongs to and then apply the formula accordingly, as I said before. Okay, thank you.